Hello, this is Mr. Frank, and welcome to I Can Find Experimental and Theoretical Probability, Day 1. So probability, it's the number that measures the likelihood an event will occur. We'll see it as a fraction, a decimal, or a percent. And the probability of an event happening can range from 0% to 100%. And here's a nice graphic that shows us at 0% it's impossible. That would be something like pigs flying. I know you can put a pig in an airplane, but I'm talking about pigs flying from one farm to another. Not going to happen. Over here, absolute certainty, 100%. Water is wet. Yes, 100% of the time, water is wet. I know you're going to say, well, what if it's ice? Well, it's still wet, but it's not water if it's ice. 100% certain, water is wet. 50-50% chance. Let's see, that would be flipping a coin. I have a 50% chance of getting a heads and a 50% chance of getting a tails. If something's unlikely, that would be like rolling a dice and getting a 3. That would be a 1 in 6 chance of getting a 3. That makes it unlikely. And how about here? If I have 5 balls and four of them are green and I want to pick a green ball, I have a 4 in 5 chance of getting a green ball. So that would make it likely. So let's look at that coin for a second. So if I flip a coin, here we go, I'm going to toss a coin. I got a 50% chance of getting a head and a 50% chance of getting a tail. Here we go. What's it going to be? I got a heads. All right, I got a heads. I had a 50-50 chance of getting a heads. And so if we look here, it was equally likely that I get a heads or a tails. I can write that as a percent. I can write that as a decimal. I can write that as a fraction at a 1 out of 2 chance. If something's impossible, it's going to be 0 chance, 0%. If it's certain, I can write it as a 1 as a number, as a 1 as a decimal, and 100% as a percent. Now, if it's unlikely, something that's unlikely, it could be 1 out of 4% chance. That's one option. I can write that as a decimal by 1 divided by 4, and I can write that as a percent. When I move from a decimal to a percent, I move the decimal 2 places to the right, and I add a percent sign. And if it's pretty likely, an example is 3 out of 4, or 0.75, or 75%. And these pie graphs show you the likelihood also by how they're colored in. So, 2 types of probability. One is called theoretical probability, and we're calculating the chance that an event will occur based on possible outcomes. This measures what should happen. So here is the formula. Probability of an event is the number of favorable outcomes divided by the number of possible outcomes. So if I'm flipping a coin and I want tails. Tails is my favorable outcome. So I have one possible favorable outcome. I can have tails or heads, and I want tails. So my favorable outcome is tails. My possible outcomes are heads or tails. I have 2 possible outcomes. So my probability of tails is 1 out of 2. That's what should happen. And that's what we would typically see. Now, how about a theoretical probability of each event here? So I want to write the theoretical probability as a fraction, a decimal, and a percent of this spinner. I'll do the first one with you. So spinning a multiple of 3. Let's see, multiples of 3 would be 3, 6, 9. I don't have 9 here. It doesn't go up that far. So I have 2 possible favorable outcomes. So my number of favorable outcomes right here is a 3 and a 6. So I have 2 of them. My number of possible outcomes, 1, 2, 3, 4, 5, 6, 7, 8, counts it for me. So my theoretical probability is 2 out of 8, or I would reduce that to 1 out of 4. Now I can write that as a decimal and a percent as well. I would do 1 divided by 4 to get a decimal, or 0.25, or 25%. So I want you to do these 2. What is the probability of spinning a prime number and probability of spinning a 5? Now, remember, 1 is not a prime number, and a prime number is where the factors of that number are 1 and itself. So what other numbers here only have factors of 1 and itself? So those would be your favorable outcomes. So I want you to do this Edpuzzle, and then you'll also do probability of spinning a 5. So do these, and then come on back. Okay, welcome back. Let's see how you did. So, spinning a prime number. There are 4 favorable outcomes. 2 is a prime number, 4 is a prime number, 5 is a prime number, and 7 is a prime number. So I have 4 favorable outcomes out of 8 possible outcomes. And then I would simplify that to 1 over 2, which would be 0.5 or 50%. How about spinning a 5? How many favorable outcomes? That would be 1. 1 out of 8. As a decimal, that's 0.125, and as a percent, it's 12.5%. So hopefully you're doing well here. If you didn't get those, go back and rewatch this slide. All right, but let's move on. Here's one. How about each letter in the word Massachusetts? I used to live there. Is written on a separate piece of paper and put into a bag. You randomly choose a piece of paper from the bag. Find the probability of the event. Write the probability as a fraction, decimal, and percent. So let's say we want to choose a T. A favorable outcome is we want a T out of all of these letters. Well, I have 2 T's here, right? So my favorable outcomes would be 2. And how many letters do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 possible outcomes. So I have 2 favorable over 13 possible. So my probability would be 2 over 13, or 0.154, or 15.4%. You're going to do this for the next 2 letters, for S and for N, and you'll bring that back to class. So go ahead and do that. Okay, let's see how you did. Or actually, we won't see how you did. We'll see how you did in class tomorrow. Bring that back, and we'll go over it in class. So now let's get to the next term, experimental probability. It's the probability that's based on repeated trials of an experiment. Sounds like we're in science now, because these are things we're actually doing. Each trial in which the event occurs is considered a success. So experimental probability is what did happen. It's what actually happens. So it's the number of successes, number of actual successes over the number of actual trials. So let's go back to that coin flip. I'm going to clear these results. And now I'm going to say we're going to flip that coin 1,000 times. 1,000 times. Ooh, this is going to be a lot. Let's see what we get. It's not going to take that long because the computer does it right away. Look at all those results of heads and tails. We're not going to count all of those. I'm just going to go here. We're going to look at the ratio. Holy cow! I can't believe it. We actually had 500 of each one. That does not typically happen. So let's actually toss it again another 1,000 times. And here, the numbers vary a little bit. I'm going to toss it another 1,000 times. And here we can see, yeah, you can see we're really close to 50%. With rounding, we're actually there. I'm going to toss it even more. This is crazy. Look how many times I've tossed the coin now. 4,000 times. 1,980 times I am getting a heads. 2,020 times I'm getting a tails. So my experimental probability of getting a heads, in this case, is 49.5%. So it's pretty close to the theoretical probability, but it's typically not the same. It's funny that on the first time I tossed 1,000 times, it was the same. It's typically not the same, but it's typically pretty close. And the more and more you flip, it tends to get closer to your theoretical probability. We'll do one more and see what happens. Yeah, that one gets really close. We're getting really close to 50% on each one. So that's kind of cool. So your experimental probability is typically a little different than your theoretical probability. Now, let's find some experimental probability here. So a cat that knows the shake command offers one of its front paws to shake. The table shows the number of times the cat offered each of its paws when asked to shake. What is the experimental probability that the cat will offer its right paw when asked to shake? So the right paw is considered success. Success doesn't have to be the bigger number. So right paw is my number of successes. And what are my total number of trials? Well, it'll be 38 left and 12 right. So there would be, you add those up, I have 50 trials. So I want you to figure out what your experimental probability is. I took you part of the way. So do that in Edpuzzle and then come on back. All right, let's see what you got. So you should have gotten the number of successes over the number of trials, 12 over 50, which would be 6 over 25. And if you put that in a percent form, it's 24%. So please capture an Edpuzzle I learned or was reminded of, and questions that I have are. All right, thanks for doing that. Hope you enjoyed the video. I'll see you in school.